Hello everyone, welcome to another integration problem. Today we'll do the integral of 2x sine x over 3 plus cosine 2x from 0 to pi. I believe this is actually, if this was a indefinite integral, it doesn't have an elementary function, but since this is a definite integral, we can do fancy tricks to solve it. Let's get right into it. So, firstly we can write cosine of 2x. We can write this as 2 cosine squared of x, take away 1. So integral of pi to 0 2x sine of x over 3 plus 2 cosine squared of x, take away 1 d of x, which is equal to integral of pi to 0 from 2x sine of x over 2 plus 2 cosine squared of x d of x cancels out. We can cancel all of this out to give integral of pi to 0 of x sine of x over plus cosine squared of x dx. Now I believe it is called king property. I can't exactly remember, but for integral of b to a of f of x dx, this can be written as integral of b function of a plus b take away x of d of x. So we can write this function as integral of pi to 0 x. So I will show two methods of solving this integral. One using the king property and the other using another integration by parts. X sine of x of 1 plus cosine squared of x d of x is equal to, so if we add a plus b, that's just pi, then take away x, integral of pi, 0 of pi take away x, sine of pi take away x, all over 1 plus cosine squared pi take away x d of x. If we expand all of this out, I believe we get, let me just look at my notes. Yes. This is all equal to just, if we just use like the sine of a plus minus b equal to sine of a cosine of a plus, sine of a cosine of b plus minus cosine of a sine of b dot, and like cosine of a plus minus b. Like if we use these formulas, we get sine of pi take away x equals sine of x, and cosine squared of pi take away x equals cosine squared of x. Okay, actually let this equal to I. Yep, so then we will have pi take away x from pi to 0 of sine of x all over 1 plus cosine squared of x d of x. Then we can expand this out into just equal to integral of pi sine of x pi to 0 over plus cosine squared of x d of x take away integral of pi 0 x sine of x over 1 plus cosine squared of x d of x. But you see, Okay, actually I'll just write it out a bit more clearly. This is equal to integral of x sine x over 1 plus cosine squared of x d of x from pi to 0. Remember we set this equal to I, so we can group the like terms together. So we can write this as integral of pi sine of x for 1 plus cosine squared of x from pi to 0 d of x take away I is equal to I. 2I is equal to integral of pi to 0 pi sine of x over 1 plus cosine squared of x d of x. We can get this out here and divide by 2. So we'll have I is equal to pi to integral of pi to 0 sine of x over 3 over plus cosine squared of x d of x. Cosine of x equal to u. So now we make this a substitution, cosine of x equal to u. Then we'll have, so this will imply so we need to change the upper and lower limit. Cosine of pi is equal to -1 and cosine of 0 is equal to 1. Then d of x will be equal to -1 over sine of x du. So we'll have pi over 2 to go from -1 to 1 of sine of x over plus u squared of -1 over sine of x d of u. Cancels out. Pi over 2 integral of -1 over 1 plus u squared du from -1 to 1. But if it's a negative, if there's a negative, then we can just switch the limits around. So we can write from 1 to -1 and to take the negative out. And this is actually just and integral of 1 over 1 plus x squared is just d of x is just equal to arctan of x. So we can just say pi over 2 of this is equal to pi over 2 integral of arctan of u from 1 to -1. This is equal to pi over 2 of arctan of 1 take away arctan of -1. This is equal to pi over 2. This is equal to pi over 4 take away -pi over 4. And this is equal to pi over 2 times pi over 2, which is equal to pi squared over 4. Okay, that is method 1. Now for method 2. So we have the integral I is equal to integral from pi to 0 of pi so pi over 2 from sine of x over plus cosine squared. We're not using the king property this time. Actually, where is it? Okay, so we go from this integral this time without the king property. I set I to this. I probably should have set this to like I2 and I2. Actually, never mind. So integral of pi to 0 of x sine of x over 1 plus cosine squared of x d of x. Okay, this is what we want to solve. So we make the trig sub cosine of x equal to u, then, okay, yeah, it's kind of similar to the previous, so cosine of x equals to u, and we saw that this will give x 1, negative 1, but the x doesn't cancel out, and x sine of x 1 plus u squared of 1 over sine of x d of x cancels. Integral of 1 to negative 1 of x over 1 plus u squared d of u. So cosine of x equal to u. So inverse cosine of u. This implies inverse cosine of u will be equal to x. So this is equal to negative 1 of arc sine of u over 1 plus u squared d of u. Now we make the this usually would not work, but since this is a definite integral, we can do fancy stuff with it. So integration by parts formula is integral of u dv over dx is d of x is equal to uv, alright, from b to a is equal to uv from b to a, take away integral of b to a of du over dx v d of x. So we set so for this integral we're integrating, we set 1 over 1 plus u squared to dv over dx, which implies v is equal to, we saw from before, arc of x, and we already have the function u. I just set that to t then, and inverse cosine of u equal to t, which will imply d of t. dt over du is equal to 1 over square root of 1 minus u squared. So this implies dt, oh no, implies du is equal to divide this dt over du, negative 1 over square root, du is equal to, yep, negative square root of 1 minus u squared dt. No, right. I know, I don't need this. My god. Right, I just need dt over du is equal to 1 over square root of 1 minus u squared. That's all I need. I had a bit of a brain fart. So, integral of 1 to negative 1 arc cosine of u over plus u squared d of u is equal to arc tan of u arc cosine of u, take away integral, this is from 1 to negative 1, integral of 1 to negative 1 of 1 to negative 1 of arc tan of u over square root of 1 minus u squared negative du. So basically this function is, so basically, integral of arctan of u over square root of 1 minus u squared d of u. So actually, if we set f of u equal to, this is actually just an odd function. Yeah. Oh no. This is just an odd function. Arctan of u is arctan of negative u is equal to negative. By the way, arctan is just inverse cosine of negative u. It's equal to negative arctan of u. And if we just square it, and u squared is just u, so this will become an odd function. So, and then if we integrate an odd function from negative 1 to 1, that just cancels each other out, and that will become 0. So negative 1 to 1 is just equal to 0. So what we need to worry about is integral of 1 to negative 1 cosine of u over plus u squared d of u is equal to arctan of u cosine of u from 1 to negative 1 take away 0. This is equal to arctan of 1 cosine of 1 take away arctan of negative 1 cosine of negative 1. This is equal to cosine of negative 1, I believe, which is 0. Yeah, yeah, I just checked with my calculator, it's just 0, so this is 0, take away, arctan of negative 1 is negative pi over 4, and cosine of negative 1 is pi. So this gives us the same answer, so pi squared over 4 like before. Thank you everybody for watching this video. Hopefully you enjoyed. Comment any requests you have, if you have any. And see you guys later.